All right, this lesson is on a review on the rules of exponentiation. Now this is review for you guys, but it's things that you do need to remember. So please make sure you're writing down your notes in your notebook. And today I'm going to start off with the lesson, and then I have answer key for the practice problems down below. The practice problems are on your Google Slides. Okay, so this is Unit 7, polynomial functions, and the first thing that we're going to do is we really need to understand exponentiation, and that's exponents, and kind of practice that before we even dive into polynomials. Now, polynomial is an equation, it's an equation, yeah, but it's any equation greater than, poly meaning many. So if we have x to the second, that means multiple x terms. That's a polynomial. But what we're looking at later on is we're going to take a look at crazy equations like this one on a graph. And we're going to talk about maximum, min. We're going to talk about how to divide, how to add polynomials, all in this unit. Okay, so let's go ahead and take a look overall in what we're doing today. So we're going to review rules on exponentiation. We'll start off with the basics. These are review for you guys, but this is good to have in your notes. So, looking at the rule first, if we have a to the m times a to the n, we're just simply adding the exponents together. So when you multiply bases, first of all, the bases have to be the same in order to add the exponents. All right, so notice how the bases of x are the same. The coefficient 4 and 6, we just multiply those together. So 4 times 6 is going to give us 24. Okay, but what we're really looking at is the x values. So those are the same. We can go ahead and add 3 plus 5, and that's going to give us 24x to the 8th. And that is when the bases are the same. Now, whenever we have a power to a power rule, we need a little bit more than adding those. So what's a little bit more than adding? Multiplying. Okay, so whatever you have a power to a power, you have to multiply the exponents. All right, so we also have to remember that that number has an exponent as well. So that's really 2 to the first power. So we're going to take 2 to the first power, and we're going to multiply that 1 by 3. And we are also going to do the same thing with the 4 times 3. And when we simplify that, you do want to simplify it all the way. So 2 to the third power is really 2 times 2 times 2, which is 8. And then x, 2 times 3 is to the 12th power. So it'd be 8x to the 12th power. And that is power to a power, which we'll use a lot of today. All right, now, when we ever have to divide bases, so when dividing bases, okay, you need to subtract. I'm also going to talk about another way to see it when we get to a few practice problems, okay? Because if you subtract and you have 9 minus 2, that would give us only 7 x's, okay? And the reason why we're subtracting is if there are 9 of them up here, 1, 2, 3, 4, 5, 6, 7, 8, 9, and there are 2 in the denominator, x divided by x is just going to give you 1. So essentially, you're subtracting the 2 that are in the numerator as well. Another way to view that is, and I'm only going to focus on the x's right now, is where do you have more x values, in the numerator or the denominator? You would say the numerator. How many more? 7 more. So in a way, you're subtracting, but you won't get stuck or in the process of like if it was -7, that would be in the denominator, but some people have a hard time with that negative portion. And then don't forget, you do have -4 divided by 20, you have to simplify that. Okay, so 4 and 20, if we divide out a 4, that would just be negative 1/5. So ultimately we would end up with negative negative x to the 7th power, all divided by 5. All right, let's go ahead and take a look. I'm going to leave those on the top and kind of scroll up a little bit slow. If you need more time to pause and you're in the class, please make sure you let people know. And if we have a negative in the denominator, notice how we need to do something about that. So if there is a negative in the denominator, it needs to move up. Okay. If we have a negative in the numerator, it needs to move down. In fact, I think I'm missing an example here, so I'd like you to add one. So if you have a to the negative m divided by 1, that's going to equal 1, because this whole thing has to go down because it is a negative exponent. So it's going to end up being 1 divided by a to the m. Okay, so the example that I'm missing here is 4x squared to the negative 2 divided by 3. Okay, and if that didn't have a fraction, there we go. What we would do is we would create that fraction, because this whole negative portion does need to go down. So we would make it over 1. So we would rewrite this as 4 divided by x squared, and then y to the 3rd. And that would be that example. Now if it's negative and it's in the denominator, it needs to move up and change from the numerator to the denominator. And that's where that would just become positive once it moves from the numerator to the denominator. So if it's in the denominator, just move it up, and then see if anything else can simplify. Later on, multiple things will be happening at the same time. At this point, I just want you to see that z to the 4th goes up, 5y to the 3rd stays in the denominator. Okay, now, whenever we have a fraction, we're going to do the same thing we would with power to a power, okay, and you would multiply those. So it would just be a to the n equals b to the n. We're going to do the same thing here. Now do remember, if it's an exponent, it's a power to a power rule, so that would be 4 to the 3rd divided by 5 times 3. So 4 to the 3rd is just going to simplify down to 64, and then 5 times 3 is going to give us x to the 15th. All right, so that is when you have a fraction to a power. And when we have two variables, and it's to a power, we're just going to make sure everything receives that in. So we're going to do that for each exponent. So that would end up being x to the 2 times 3, y to the 1 times 3, and z to the 4 times 3, which would just equal x to the 6th, y to the 3rd, and z to the 12th. All right, now if that number is negative, that's where we get into something interesting, because the entire fraction is going to end up becoming a to the negative n, b to the negative n. Well, remember, whenever we have a negative in the numerator and a negative exponent in the denominator, we need to switch those so that they become positive. And in order to switch them, check that out. A and b just switched, that n value became positive. All right, so we can go ahead and take the reciprocal of the inside of the fraction, and that's just going to become 3y to the 4th divided by 2x squared. Now it all became positive. Now you can go ahead and distribute in a way that's squared, because it is a power to a power rule going on with a fraction. That looked a little messy. I'm just going to go ahead and do one step at a time here. So it's going to be 3 squared y, 4 times 2 is going to give us, well, I can write that out, and then we'll do one more. And then 2 times 2 to the squared, and x squared. Okay, simplifying life here. So 3 squared is going to give us 9. y to the 8th divided by 4x squared. And there's nothing else we can simplify out of 4 and 9. We are done. Okay, last example of our exponentiation rules, and then I'm going to have you guys practice, is a to the mn, okay, is going to become a radical. We talked about fractional exponents in our last unit. Whenever the numerator is going to become your exponent. Your n value is your root or index number, and this is your exponent. All right. So first things first, we're going to go ahead and set this up into exponent form. It is an exponent form. We're going to set it up into radical form. So our root is 3, so it's going to be to the 3rd root, and it's also going to be squared. Let's go ahead and simplify on the inside. Whatever is in the inside of this parentheses becomes your radicand, and that whole thing is squared. So let's go ahead and simplify that before we can do anything else. So 2 times 6 is going to give us 12, but we also have 8 squared, which 8 squared is 64. X to the 6, 12. Okay, and then looking at what we can simplify here, we would have 64. Let's see if 64 can be broken down into groups of 3. So I'm going to bring 64 out here. We have 8 times 8, 2 and 4, 4 and 2. Okay, and we're looking for groups of 3 numbers. Check it out, we've got some. Okay, so the cube root of 64 is just going to give us 4. And then if we were to simplify this, this would be 12 divided by 3, which is just 4. So this whole thing becomes 4x to the 4th. All right. Okay, what I'd like you to do now is you're going to pause the video. I want you to use this time to go ahead and simplify these all the way to the answers. I'm going to provide answers for you, and then hopefully you can go to tutoring if you do not understand how one of these simplifies down, or hopefully you have a chance to talk to partners or ask to go into a breakout room so you can talk to a group and ask someone in your class how one of these problems breaks down. But I'll provide the answer key here shortly, and that way you can take a look at it on the video. Okay, so these are the first 6 problems. Hopefully you gave yourself plenty of time to go ahead and practice those first 6 problems, and you're just checking your answer for right now. I'm going to leave this on here for a second, and then I'm going to go ahead and move down. Please pause the video at that point. All right, here's 7 through 12. Again, please go ahead and pause the video. I'm not going to leave like long time frames in between because different people work at different paces, and I get that. And I really hope I don't have any typos on here. If I do, don't kill me. You just talk to each other and make sure you guys got the same information. And if you did, whoops, I have a typo somewhere. But I don't think I do. I tried very hard. Okay, here's our last slide. Now this one was a little bit harder because they were word problems. 14 in particular, you did have to set it up as far as this is your area. Let me do it in another color. So the area is 10x, y to the 4th, z to the 3rd, and then we knew that the height was 2x, y in the base of the triangle. So you needed the formula, and your area would have been 10x, y to the 4th, z to the 3rd equals 1/2 base, which we don't know, times our height, which is 2x squared. Half of 2 is 1, so those simplify, and you're left with x, y, and then we're going to divide both sides by, I don't know what that was, x, y. These become 1, you're left with the base equals, that becomes 1. Y to the 4th minus y1. It's just going to give you my y to the 3rd. So you're left with 10y to the 3rd, z to the 3rd. All right, and then the perimeter and area of a square, you needed to think about what those formulas were, and you could go ahead and substitute that 10x to the 4th times y into one of the sides of the squares, and go ahead and either square it or multiply by 4 for perimeter. Hope you guys did okay. If you're struggling with this, please go to tutoring and get the help that you need in order to be successful. Okay, so go to the tutoring schedule. I'm hoping that those links are going to be there. If not, if it was an email that was given, make sure you save those links. I'm going to try to put them in many places as you can see them. I don't want you guys to be shy about going and seeing another teacher. Mr. Bull's doing geometry, but Miss Young is awesome, and she will also, if you want to work with a peer tutor, you're welcome to do that as well. Just let her know, and she'll get you set up with somebody, okay? Have a wonderful day, and I hope everything's going well. Bye.